Let's talk about equivalent fractions. Take a moment to study the two models shown below. In the first model, we see that one of the two equal parts is shaded in blue, that is 1/2. In the second model, we see two of the four equal parts shaded in green. Are the fractions equivalent? Yes, because if you look at the shaded portion, they are the same size and cover the same portion of the whole. Let's try another example. What fractions are represented by the circle model shown below? The first circle model represents 5/6 shaded, and the second circle model represents 3/6 shaded. Are the fractions equivalent? Let's take a closer look at their shaded portions. The shaded portion in 3/6 is smaller than the shaded portion in 5/6, and 5/6 has a larger shaded portion than 3/6. That means the fractions are not equivalent. If we look at the two fractions and how they were written, we can see that their denominators are the same. That means each part of the whole is the same size for each fraction. When we take a look at their numerators, we can see that 5 is greater than 3. That means the fractions are not equivalent. Now let's try a number line example. What fractions are represented on the number line shown below? The star is past 1/2 and it's really close to 1. That means the fraction might be 5/6, 4/5, 7/8, 11/12. This fraction is 7/8. Now if we take a look at the second number line, what fraction could be represented? The second number line star is really close to 0, so that's probably about 1/8. We can see that the fractions are not equivalent because they are not at the same distance from 0. One is closer to 0, one is closer to 1. That means the fractions are not equivalent. Think about the fractions 1/3 and 1/10. What is a statement that can be made to describe the fractions? Let's think about their denominators. We know that thirds are larger than tenths because 3/3 equal 1 whole and 10/10 equal 1 whole. If we look at the models on our screen, we can see that 1/3 is a lot larger than 1/10. The fractions are not equivalent. Now let's think about the fractions 4/3 and 11/10. What do you notice about the fractions? One thing that I notice is that 4 is greater than 3 and 11 is greater than 10. That means the numerators are larger than the denominators. Let's take a look at how that looks in a picture form. Here are 3/3 and here is 1/3, that is 4/3 or 1 and 1/3. Here is 10/10 and 1/10, that is 11/10 or 1 and 1/10. The fractions are both greater than 1, but they are not equivalent because we can clearly see that 11/10 is smaller than 4/3.